Hello everyone. Today let's solve the problem number 312, burst balloons, right? So what the question states here, we are given n balloons. You can clearly see here we are given n balloons, each with a number painted on it. So these are the balloons, right? So we are given n balloons, each with a number painted on it, represented as an array nums. You can clearly see here. When we burst the ith balloon, we will gain the coins equivalent to or equal to nums of I minus 1 into nums of I into nums of I plus 1, right? So when we burst the ith balloon, we will gain the coins that is equal to nums of I minus 1 into nums of I into nums of I plus 1. Previous one, the current one, and the next one, right? So when I say nums of I minus 1, nums of I and nums of I plus 1, I am speaking of suppose just give me a second. If we burst this one 5, then it is nums of I current one, this one, and this one. Means 1 into 5 into 8 we have to consider in this case, right? So that's what they have given here as well here, right? When we burst 3, it is 3 into 1 into 5. When we burst 5, it will be 3 into 5 into 8. And when we have only 3 into 8, this will be considered as 1. 1 into 3 into 8. 8, it is 1 into 8 into 1. Suppose if we don't have elements, we will be going with 1, adding 1 previously and adding 1 forward as well, right? So next element will be adding 1 and the previous element will be adding 1 as well if we don't have any element. So this is empty. So that's what they have given here. When we burst 3, it will be 3 into 1 into 5. 3, 5, 8. So this will be 3 into 5 into 8. Again 3, 8. For 3, 8, it will be 1 because we don't have previous number. 1 into 3 into 8. For 8, it will be 1 into 8 into 1. Previous and next element we don't have, so we'll consider 1. This case we'll leave it as it is. So when we sum up this one, it will be 15 plus 120 plus 24 plus 8. So this will be 15 plus 120 plus 24 plus 8. In this case, it will be 167. So you can just sum up this one or add all the numbers here. 15 plus 120, this will give us 127. So that's what they have given here. Simple to understand, right? So this is the question, right? Basically, so we treat it as so we are given n balloons, each with a number painted on it, represented as the array nums. When we burst the ith balloon, we gain coins that is equal to nums of I minus 1 into nums of I into nums of I plus 1. If I minus 1 or I plus 1 is out of bounds, we treat if there is a balloon with a 1 painted on it. That's what I said. If we don't have the previous element or if we don't have the next element, then we will consider 1 in that place. If we don't have I minus 1 or I plus 1 element, then we will consider as 1. Nothing but if I minus 1 or I plus 1 is out of bounds, we treat if there is a balloon with a 1 painted on it. So what is our main goal here? Our main goal is to find the maximum coins we can collect by bursting the balloons in an optimal order. Means number of maximum coins that we can collect, that we have to find out by bursting the balloons in optimal order. So that's what we need to find out. Same goes with example 2 as well. You can just try it out in this way itself, right? I hope the question is completely clear what we need to do, right? Simple to understand, right? So first what we'll do, let's discuss the approach step by step. Let's discuss the approach step by step, followed by edge cases one by one, and finally write the complexities of the code. Finally write the code and discuss the complexities of the code, right, that we have written. Initially, as usual, let's discuss the so here you can clearly see the first example that they have given in the question. Same thing I have considered here as well, right? So we will be making use of 2D dynamic programming, or we will be using 2D dynamic programming approach to solve the problem. So the first question, same thing they have mentioned, that itself I have considered here. So this will be 167. We already discussed this one, right? So let's go step by step here. So here what we will do, is we'll be making use of the 2D DP or 2D dynamic programming, right? So here the first step here is we will modify the array. We will add 1 at the beginning and as well as end. So this array becomes here 1 3 1 5 8 1. We are adding 1 at the beginning as well as the end. Then we will define the DP state as it is 2D DP. DP of ij stores the maximum coins that can be obtained, right, by bursting the balloons in the range I comma j, right? That's what we'll be doing. So we have to fill the DP table now and finally compute the final answer. Final result is stored here in the sorry, just give me a second here. Let me write here itself. So final result is stored in dp of I into n minus 2 in this case, right? So dp of I into n minus 2. The final answer is stored in dp of I into n minus 2. Why? Because we have added this one and 1 at the beginning and 1 at the end. So we are considering n minus 2 here instead of dp of 1, right? So this will be dp of 1 n minus 2. I hope this is clear. The final answer is stored in dp of 1 into n minus 2 since nums was expanded, right? One, we have added 1 at the beginning and 1 at the end. So let's see the step by step breakdown for the example that we have considering, right? So first what we will do, we will burst the first we will burst 1 first, right? So this will be, in this case we'll burst 1. This will be 1 into 1 because previously we don't have any number here, so we will consider this one as 1 itself. So I'll just come here, let me consider red here. 1 we will consider here, 1 into 1 into 3 here, right? So this will be 1 into 1 into 5, I think. Sorry, what did I miss here? So yeah, burst 1 first, right? So we are going with this one, not this one. So this has to be 1 into, I got confused here, 1 into 1 into 5 this will be, right? So this is fine. The second here is we will burst 3 here. This will be 1 into 3 into 5, this one, right? 1 into 3 into 5. So this will be, when we burst 3, 1 into 3 into 5 it will be, right? So the third one will be, we will burst 5. So gain will be, we will burst here. In this case we have, second we bursted 3, third we are bursting 5 here. This one 5 we are bursting. First we went with 1, second we went with 3, third we are bursting 5. When we burst 5 here, we will consider 3 into 5 into 8 here, right? So this is one thing. So next step here is, finally we will burst 8. When we burst 8, it will be 1, this one, burst 8, right? Here, this is fine. So here this will be 1 into 8 into 1. This will be actually 5, and 3 into 5, this one will be 15. 3 into 5 into 8 will be 120, and finally 1 into 8 into 1 will be 8. Here we'll sum up this one, 5 plus 15 plus 120 plus 8 here. So this will be 120, 135, 140, 148 we are getting. So here somewhere we have missed something, right? Here, so just give me a second here, something I missed. So calculation here I have done wrong here. Let's calculate this one again actually. So let me come here. Let me give nums equals 3158, right? So we are adding 1 at starting and 1 at the end. This will be 13158. So first thing here will be, we will burst 1, right? So when we burst 1, coin gained here is 3 into 1 into 5. So I did this one wrong actually. This will be 15. Second step is, we are bursting 3 here. First step we have burst this one. Second step is we are bursting 3 here. Sorry, we can go with bursting 5 here. So we are not at bursting 3. We will burst 5 here, or we can go for, we can burst 3 itself. So when we burst 3, it will be 1 into 3 into 8. This will be 24 basically. Third, what we will do, we will burst 5 here. Let's burst 5 here. So this will be 3 into 5 into 8, which is equal to 120. And the fourth one will be, we have to burst 8. In this case, it will be 1 into 8 into 1. This will be 8 itself. So overall, it would be 120. Yeah, this will be 15 plus 24 plus 120 plus 8. This will lead to 167. So 24, 34, 39. 120 plus 39 equals 159. 159 plus 8 equals 167. This is fine, right? So here the total coins here is 167. So 167, it is equivalent to the output that they have given in the output. So I got confused here. Sorry. This is the correct step basically we need to follow, right? So we went with the 2DDP, right? So the solution that we got here is 167. I hope this is the approach that we will be going with. I hope the approach is completely clear. Let's go with the edge cases one by one, right? The first edge case that we'll be considering here is this one, single balloons. Here you can clearly see nums of only one element here, single balloon, right? So this one output will be 1 itself, as we are going with only one balloon. And the second, because it will be 1 into 1 into 1, right? So here let's consider two balloons in this case, 1, 5. This will be, output will be 10. You can just calculate in the same way, right? I minus 1 into I plus I plus 1. I minus 1 into I plus I plus 1, right? So third one will be here, all balloons have the same value. Here you can clearly see 2, 2, 2. All balloons have the same value, right? This one should still, it has to still work optimally, right? Big numbers should work optimally. So you can just calculate in the same way that I showed for the that I showed considering the example one, right? So here balloon with 0 values, so the 0th balloon doesn't contribute to coins, right? So here this one should be handled carefully for 0. So we are not going with the particular output. Basically, what are the cases that we need to handle? That one we are just considering here. This one has to be handled carefully for 0, and here big number should be should work optimally, and here for the single balloon end we have to consider the edge case for the two balloons. I hope these edge cases are completely clear. So these are the 4 edge cases that we need to keep in mind, right? So now let's start writing. Here let's start writing the code. First step, we have to add the boundary balloons with the value 1 that we saw, right? So we are adding it beginning 1, and we are also adding the 1 at the end. So how can I articulate that one in the form of code? Nums equals 1. So within the array we have to do this one, right? Spread operator of nums comma 1. So just give me a second. So here the first step is we are adding the boundary balloons with the value 1, right? So we have discussed this one already. So step 2, let's define the DP array. So n equals here length of the nums. So also we have to define the DP array, right? So this is 2D DP array. So I'll just go with array of n, array of size n. Let's make use of the fill, and let's go with the map here, array of n, and let's fill this one with 0. This is fine. So next step here is let's fill the DP table. When I say let's fill the DP table, here we'll be going with the 3 for loops. So this will be basically n cube. We can also do it in no, we have to go with 3 calculation, 1 into something, current one, previous one, and the next one, right? So let's go with the 3 for loops here. So let w equals here 1, w less than n minus 1 here, and this one w plus plus. W I have considered because we are going with the window size. W is short form for window, right? Window size. So next, let's go with another for loop here. Let s equals 1, e equals w. So here e less than n. So this one has to be comma. This is fine. Equals n minus 1. This has to be, and let's increment the s. Went the e here. This is fine. So what we did here, s is nothing but the start and e is nothing but the end here. So this one w is window size, just for the understanding purpose. This I'm telling. So this is s is start, this one is end. You can just take the complete name as well. This you can consider window or window size. This is start and this is end, right? So the next step will be, let's choose I as the last balloon to burst, right? So here again one more for loop. Let I equals s, because we are considering I as the last balloon to burst. I less than or equal to n. Let's increment the I. I hope this is clear. Next step, let's write the formula. So dp of s e, as we are going with 2d dp here, this will be, we have to consider the max here. Dp max of dp of s e, comma dp of s I minus 1 plus nums of I current value. This is previous value, dp of se, comma dp of s minus 1. This is previous value. This is current value. This is nums of I. Then what we have to do? This one has to be into nums of I into nums of n plus 1 plus dp of I plus 1 into e here. So this is the formula that we'll be going with. So I hope this is clear. Then what we will do, the next step or the final step is, we have to return the maximum coins that is being collected. So we have already discussed this one. This will be at the dp of 1 into n minus 2, because we have added 1 at the start and 1 at the end. We have expanded the array, right? Dp array by 2. So it finally we have to return n minus 2. So this will be a return. So yeah, dp of 1 into n minus 2, dp of 1 into n minus 2. This is fine. Let me format the code once and let me hit the run button. So here something e has already been declared. So here what did I do in the line number 8? So this has to be equals, or so this I have done wrong here. Just a second. This is fine. So this is fine. Here this has to be semicolon. So let me hit the run button again. Wrong answer. So let's check what is wrong. So here what mistake I have done here is, in the line number 11, it has to be dp of s into I minus 1 plus nums of s minus 1 here. I hope this is clear. So let me format the code once and let me hit the run button again. So I hope this works. Let's see. So yeah, now you can clearly see the sample test cases are getting passed here. So the code works. I hope the code works absolutely correct. Let's see. Let me hit the submit button. Yeah, you can clearly see the all the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities for the code that we have written. So the time complexity here would be the approach that we went with here is dp on intervals, right? So we know this. We went with dp on intervals. So overall time complexity would be here big O of n to the power of 3, or big O of n cube. What will be the space complexity here? Overall space complexity would be here, and this case would be big O of n to the power of 2. So overall time complexity would be big O of n cube, and overall space complexity would be big O of n square in this case, right? So I hope this is clear, right? I hope the solution or the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.